Hello, so today we have an 820-3115 board with no backlight due to liquid spill. So first thing I did was make a measurement around this chip from backlight to ground. So here's my Fluke multimeter. So I put this thing in diode mode, put the positive on ground, and I'm going to put this up so you can see it. Oh, this is ghetto. Oh, this is just getting more and more ghetto. Okay. So, and the measure, what I did is I took my positive end here, and I put it on ground, and my black one, and I put it on the output of backlight. And I got something like 0.568, actually no, in the beginning, I'm sorry, I got 0.01 something or 0.1 something. Now, what diode mode measuring does is it tests the continuity between ground. Oh, you distracted me. My video is ruined. They're not going to pay for it now. Alright, so what diode mode does is it measures the drop in voltage across 2 points. Now, any amplifier, any boost circuit of any kind has some connection to ground. So you're usually going to see one of two things. If the output is not attached at all, you're going to see something high. And if the chip is fucked and shorting the ground, you're going to see something low, like 1 or 0.2. So I had like 0.1. I replaced the backlight driver, and it still had, now it went up to like 0.6 or 0.68 or 0.59. And on a working board, this is usually 0.526 to 0.538, around there. Now what that tells me is that something that's supposed to be connecting to ground is not. Now let's look over here. So this is the output of backlight over here. That's the output of backlight. This is the chip over here that creates the backlight. So let's see, what could possibly be missing? Now, over here we have where the boost output is, right? And over here is another thing attaching back to the chip. This just goes to feedback. Now, if something's missing the ground, what that tells me is most likely, or if my diode mode measurement is too high, that means not enough voltage is going to ground. That means that something that would be going to ground is missing. So what I'm assuming here is the chip itself has ground connections, and this feedback trace over here, PPV SW backlight FUB, which is feedback, which is the chip seeing what it's putting out, may be missing. Because again, my measurement on diode mode was too high. It said that there was a 0.6 voltage drop to ground instead of 0.531 or 0.538. So what that tells me is that one of the things that's going to ground is missing. Now all of this stuff was fine. 99% of the time, all that's fine. So what does that mean? That means one of these capacitors is bad because these are things that go to ground, or this feedback trace is broken because the feedback trace goes back to this chip, and this chip itself has connections to ground. Again, these capacitors, you can check them 99.99999% of the time, they're just fine. And I took the chip off, and what I saw underneath this was just a horror show. I mean, the fucking pad was half there, the via was missing, the trace was missing. It was a nightmare. So you can try to solder a wire under a BGA chip. Very good fucking luck to you doing any of that kind of shit. But, so here's what I wound up doing here. And it still looks like crap. I gotta clean this up. So I got this conductive pen, which, by the way, I endorse this. You should buy this, the CW2200 MTP. I've used different conductive pens before, but the cool thing about this is you can actually solder to it. So after you draw your trace, you can make a little ball right at the end, and you can actually fucking solder to that, which is amazing for when you have a problem with something underneath a BGA IC. You don't have to run a wire to it. There are a couple of things you can do when you're trying to solder underneath a BGA chip, and one of the things that makes the most sense is to use lead-free solder to solder your wire underneath the chip, and then use a leaded solder balls on the chip so that the connection doesn't actually get fucked up again when you put the BGA chip down. But there are a couple of things about that. The first is that I don't plan on reballing something that's this small. I don't like reballing in general, but reballing there's 25 balls under there. You get the fuck out of there with that shit. And the second thing is, I find when if you try to do that with a smaller chip, even if you use the finest wire on earth, it still lifts the chip up. And it lifts the chip up on the end, which completely fucks its ability to get soldered onto the board. Because again, you have 25 balls and something that's holding up something this light and small, and if you have a wire that's going underneath the chip, what I find happens is that the wire that's going underneath the chip actually lifts it up, and it's just it's a nightmare. If you don't believe me, try to do it and you'll see it's a fucking horror show. So what I did here is I drew with that pen from the pad underneath the chip, from the feedback pad, which is luckily on the corner, right outside the chip to where that probe pad is supposed to be, because there's supposed to be a probe pad outside of the chip for the feedback. Now, see these things? These are what I mean when I say probe pads. See these little circles? So those are actually solderable, but they're points where you can measure. So let's say you'll have a trace going here, and then the trace will go to its destination, but it goes through this little thing. So this allows you to measure points that you otherwise would not be able to measure because they're difficult to get you, and it also allows you to jumper wires between points that are missing. So there's a probe point outside of there, and it's just completely gone and sodomized to shit. You can see right here where it's supposed to be. Yeah. Let's see how close I can get before my camera gives out. Yeah, we're not getting any zoom on this cheap piece of shit. Let's see if I can actually put it in the microscope. Because I may be able to put it in the microscope and then try to film through the microscope. That would be cool. So, alright, so what I edited out is, as I actually was walking over here, I ripped the wire off of the motherboard to go to the microscope. Yep, you can laugh. You can laugh all you want. Alright, so let's see if I can get a picture of this in here. Alright, so there's no way in hell I can get a picture of that in the microscope. But yeah, you can get the gooseneck light up there. Yep, that is fuck shit. So, we reattach the feedback trace, and the shit still didn't work. So what comes next? Well, I measure. Output of backlight, nothing. Here, diode, nothing. Inductor, nothing. Other side of inductor, nothing. There's supposed to be 12 volts running along here before it gets to the boost. Now, Q706, I have my 12 volts over here, so this is open. But there's nothing between here, which is PP bus SW booklet per, and here, which is PP bus SW booklet. Well, this is supposed to feed this. So this 12 volts is coming from this opening. And it's kind of confusing because it doesn't actually say the exact same thing over here as it does over there. But again, you should just use your fucking brain and figure it out. Or you can check on a board that works. You beep this to this, and by beep I mean continuity testing your multimeter. So that's what the second wire is for. The second wire is going from here to here to attach my 12 volts. Now, do you think this Frankenstein-looking crap works? Well, usually in the last few videos I have been lazy and I haven't actually shown you if the work at the end does work. But since this is so, I mean, I barely believe that this shit works myself, which is why I'm gonna plug it in and show you that it does. This is a Haswell board, so it will turn on by itself. I don't have the fan on. A lot of the times I have the fan and the heatsink on for the old, especially for the older shit. As you can see, it's lit up. Actually, you can't see because of all the LEDs. You can barely tell that this thing's on. But when I unplug it, you can see it turns off, which means that the light turned on. And again, my main thing with all these videos is I'm not trying to give you a how-to guide on how to fix any of these problems. I'm not trying, because every single one of them is a different problem. You can't apply a solution where the Q9706 is not attaching to L9701 to a motherboard where F9700 is not attaching to Q9706. You can't apply each of these specific solutions. What I'm trying to do is show you that you can use your brain to figure this out, and that you need a lot less brain power than you probably think you do to figure out these issues. And that's pretty much it. Again, I want to see you use your brain more before you ask questions and before you give up and before you make excuses as to why you can't figure something out. Because I assure you, the solutions are out there. You know, I can't get under a VGA chip. I buy a pen. Again, just don't say, oh, this is so small, or oh, that's so impossible. Small? Get a microscope. Can't get under it? Buy a pen. You know how to write, don't you? Okay, cool. Draw a line. You don't even have to have good handwriting. If you saw my handwriting, you'd see that it's, you know, this is pretty much the only thing I know how to actually write with. And, you know, that's really all there is to it. Just use your brain. If I can do it, I guarantee that you can.